Okay, today we're going to solve systems of equation using elimination. This is our third way or method to solve a system. Our first method we looked at is we could graph it. And when we graphed it, we looked at the intersection. The second way that we learned how to solve a system is by substitution. And then the last way is what we're going to look at today is elimination. And it's really my favorite. I think it's the easiest. And your book will use the term addition subtraction method. So when you see solve by the addition subtraction method, that's what I usually refer to as elimination. So let's look at example 1. If you're going to use elimination, there's a few things you need to keep in mind. We typically will put our equations in what we call standard form. And so here we have our x's lined up, then we have our y's lined up equal to our numbers. So when that's the case, and most of your homework problems are already lined up for you, when that's the case, what I want to try to do is I eliminate a variable. That's really the goal, is to eliminate a variable. So if I make one big addition problem, what is that going to do? Let's look at that. So I'm going to basically add those two equations together. So let's look at the first. We've got x plus another x. We're just adding like terms. So when I do x plus x, I get 2x. Now let's look at the y's, and if I add these like terms together, I have y plus, now notice I really have a negative y there because it was minus y. So that's really y plus a negative y. And if I were to add those together, that's really 0 y's. Well, what happened is we just eliminated the y's. I won't always write that 0 y there, just for the first few times. And then our numbers, let's go ahead and add those so we don't forget. We have 14 plus 4 is 18. So now I can just simplify. 0 y's, that really goes away. That's like 0 yo-yos. I don't have any yo-yos. So I really just have 2x equals 18. And then it's a one-step equation. You can divide by 2, x equals 9. Now we're not finished. We know the x value, but I still have to find the y value. So I pick the easiest equation for me. And so the easiest equation for me is x plus y equals 14. And then I plug in what I know. I know that x is 9. And I just need to find y. You could probably do this in your head, but if not, you just subtract 9. And so y is 5. So then to write my final answer, I'm going to write it alphabetically. 9, which is my x, comma 5, which is my y. And then, remember, it needs to check in both. So the great thing about systems is you can plug it into both equations and make sure it works. So look at that first equation, x plus y equals 14. Well, what is 9 plus 5? It's 14. And then plug it into x minus y. So that's 9 minus 5 equals 4. So as long as it checks in both, you've done this correctly. If you were to graph these equations, the intersection where the lines crossed would be 9 comma 5. Okay, let's look at number 2. Number 2, we have our variables lined up. So notice we have r's instead of x's. We have s's instead of y. So we're going to, our final answer, just to kind of keep in mind, is going to be r comma s. It will be alphabetical, just like a comma b or x comma y. And then we have our numbers. So if I were to add these right now, really nothing would eliminate because 3r plus 3r is 6r, so that didn't eliminate the r's. And 2s plus s is 3s, so that didn't eliminate the s's. But I have to keep in mind when it's an equation, I can do whatever I want as long as I do it to both sides. So what I prefer to do is I prefer to take one of these equations. The first one I'm going to leave exactly as it is. I'm just going to write 3r plus 2s equals 2. But on the second equation, I really just need that second equation to end up with a negative 3r. Well, how would I do that? I could just multiply by negative 1. So remember, I have to multiply the whole equation by negative 1. So it's going to be negative 3r minus s equals a negative 7. So what I did is I just took this whole second equation, I multiplied through by negative 1. So notice the only thing that changed was the sign for each term. Now, I'm going to kind of highlight these two equations. Now, if I add these two equations, do I have something that it eliminates? Now, I always prefer you to add. I think students that try to subtract make mistakes. So that's why I will always use addition. I'll multiply through by a negative to make sure that I change all the signs, but then I always use addition. Typically, students do much better. So now when I do 3r plus a negative 3r, that's 0r. That's going to eliminate, which is good. And then I have 2s plus a negative s, which is going to give me a positive 1s. And you could write that just as s, which is fine. And then you have a 2 plus a negative 7. And so that's going to give me negative 5. So if I simplify, what really was happening, right, are these variables are eliminating. And so I have s equals a negative 5. Now I'm not done yet because that's only part of my answer. And so I'm going to pick the easiest equation for me, then 3r plus 2s. And actually the second equation may actually be easier, but I'm going to go with this one since that's what I started with. So 3r plus 2 times, I'm going to plug in my s, is negative 5. And then I'm going to finish my problem. So I have 3r minus 10 equals 2. Then if I were to get r by itself, I would add 10 to both sides. So I have 3r equals 12. Divide by 3, r equals 4. So my final answer is 4 comma negative 5. And keep in mind, you should check that in both equations to make sure it works, but I know it does. And there's 9-4.